Hi and welcome. In this part of the video we're gonna talk about Bitcoin and quantum computing, and we're gonna discuss if Bitcoin is actually at risk getting attacked by a quantum computer, and if this could happen now already or if this is far in the future. And we're also gonna look at the parts of Bitcoin that could be impacted by quantum computing. As you will see, there is many parts that could be impacted by a quantum computer. First of all, there is the Bitcoin mining, as you will see, and then of course there is also the confirmation of the transactions, and a lot has to do with computing in Bitcoin, of course, and we will see what impact that will have. This is another part of the series Potential Risks Holding Bitcoin, and you will learn a lot in this video. So let's get started. The first thing we're gonna look at is to understand what is actually a quantum computer. It's very important to understand this. So if we talk about it, you know the advantages and the disadvantages of a quantum computer. Because a quantum computer does not have just advantages. There's also a lot of disadvantages. A quantum computer cannot do all the things very good. So if you look at the comparison table here, we can see here on the left side there is the quantum computing, and on the right side there's the classical computer. And basically the quantum computer calculates with qubits. A classical computer will just have the option 0 or 1, as you probably know, but a quantum computer can actually have 0 and 1 at the same time. So the quantum computer has much more power to actually solve the puzzle. It's working in a very different way. Here you see the scalability basically. So the increase is exponential here, and in the case of a regular computer, it's just a one-to-one relationship. And here you see quantum computing has a high error rate. So you will later on also see in the part of the video where we talk about how many qubits you actually need to break Bitcoin. And you will see there's noisy qubits, there's physical qubits, and so on. And the calculation we're gonna do will show you exactly how much physical qubits actually you need to calculate what you would have to calculate, or what the math power or the calculation power that you would actually have to produce to be a risk for Bitcoin. The classical computer has a low error rate, but of course the classical computer is much slower in solving problems. Then there's disadvantages and advantages, as we talked about. Here we see the classical computer. Most everyday processing is best handled by a classical computer, and the quantum computer well suited for tasks like optimization problems, data analysis, and simulations. So a quantum computing is very good in simulations, in analyzing data, in recalculating some stuff, and we will see this could also be a risk for Bitcoin, as maybe the quantum computer will be able soon to calculate the private key out of a public key. And this of course could be a very high risk. Let's look at the next slide. Here we have Bitcoin on quantum computing. Is a quantum computer able to attack Bitcoin? In this case, we talk about the mining part. So I separated into mainly A and B, and you will see B is again separated in some other parts. But now let's look at the mining. What could happen at the mining space? So you need to know that actually Bitcoin is mined by computers. That means the supply of Bitcoin is regulated, so it's a fixed supply of Bitcoin, and the computers, so to say, they have a race in finding or solving a puzzle, and the computer that solves the puzzle will actually get the reward. When quantum computers would come in and they would be able to hash so to mine Bitcoin much faster than regular computers. You have to know that it's not possible a long time anymore to mine Bitcoin with your regular computer with a GPU. You need an ASIC chip. ASIC chips are specially made to solve the problem that Bitcoin tries to go after. So these mathematical issues or these mathematical puzzles that you need to solve to get rewarded with Bitcoin, these chips are actually exactly made for that. So if a quantum computer would come in and be able to mine much faster, to solve this hashing puzzle much faster than a regular computer, this could be a risk, because then actually the one quantum computer would be the one getting all the rewards and would also be in control of the transactions at this time, because he's much faster. He would not be able to control everything, and there's also a security measurement inside of Bitcoin. That means if the computing power gets much higher, then actually the Bitcoin protocol will automatically adjust itself. What that means is that the difficulty will get harder. It will be much harder to mine Bitcoin, so to say, to solve the puzzle. So if a quantum computer gets in, and you see here the number, actually every 2016 blocks, the Bitcoin difficulty gets raised. So if miners drop off the network, if there is less miners, and if there is not so much security, so hashing power helps to secure the network, because every computer that is working for the Bitcoin network is basically protecting your Bitcoin holdings, is protecting the network, the security, is confirming transaction, and also mining Bitcoin. So if it would happen that a quantum computer comes in and manages to take over, then there would be the point after 2016 blocks or earlier, depends when the quantum computer went in, that the Bitcoin difficulty will go up. So also the quantum computer maybe is just for a very short time able to mine the majority of the Bitcoin. Then the network would get adjusted, and then we have a situation that we don't know how we're going to handle now, because theoretically, if the difficulty gets moved up and it gets much more difficult for the miners to mine, then theoretically there would also just be this one quantum computer be able to actually mine, because the others are much weaker. So at the moment, hashing, that's not a risk, because the quantum computer is not very good in hashing. The quantum computer, as you saw, is very good in statistics or in calculating some stuff. It's not very good in hashing. So at the moment, it's not really a risk, and we will later on look at some statistics, some numbers that will actually confirm this thesis. So the second part, as we see here, we have the encryption of Bitcoin. So here we have B, the one part is the mining stuff, and the other part is the encryption. That means the encryption is Bitcoin is using certain algorithms, certain things that makes it, of course, very hard for a hacker to come in and hack Bitcoin. And ECDSE is one, the elliptic curve digital signature algorithm, if you see here in brackets. So this would be one algorithm that will actually help to generate a public key out of your private key. And what could happen is actually that a quantum computer is in the future maybe able to hack into that, or just he doesn't have to hack first, he has to find it first, and then he can calculate it. So it's not even about hacking if we talk about it. And the private keys can actually be found if you use your Bitcoin wallet, actually, if you use the same public key over and over again, or if you have it on exchange that is using the same public key over and over again, there's actually the risk that that this public key could be seen, and the public key is also seen during the transaction period. So one of the things you can do to avoid this also in the future, if a quantum computer should be able to get or be able to calculate the private key out of your public key, because the private key is actually the key that you need to confirm your transactions. And if the quantum computer would be able to take your public key and recalculate the private key out of it, it would be able, or the owner of this information would be able to actually control your Bitcoin wallet. The second thing is that also if you just use the address one time, then the risk is very low. But theoretically, there would be the risk that during the transaction, a quantum computer could go in. During the transaction, of course, you see the public key because you need it for the transaction. And in this short time, the quantum computer could get in and try to recalculate it. This would just be possible if the Bitcoin transaction would take longer than 8 hours. So theoretically, a quantum computer would be able to calculate your private key out of your public key during 8 hours. The average transaction time here, I think it was 2020, was around 10 minutes. But there have been times where transactions have been 33 hours, or even in the peak, I think it was 2018, in the peak it was 133 hours. So theoretically, if a Bitcoin transaction takes more than 8 hours, it could be in the future that a quantum computer would be able to get your public key, calculate your private key out of that, and then what the owner could do, just put in a higher fee and get the transaction faster into the queue, and then because he has your private key, he can sign it again and can send it to his wallet basically. So in the future it could be a risk. So let's look at this slide. Here we see the past. We see that IBM managed in 2016 to have 2 qubits, Rigetti managed 3 qubits, IBM in 2016 managed 5, then IBM with 50, Intel in 2018 with 49, Google in 2018 with 72, and Rigetti again with 128 in 2019. And at the moment, what I found is that the highest number of qubits is 500 physical qubits. And on the roadmaps from IBM, for example, you find that they want to achieve 1K to 1 million qubits, which is very broad, you know. Is it 1K or is it 1 million? And you find competitors that actually saying they will achieve over 1 million by 2025. So we will see what they can achieve. It grows so fast and it's very hard to do that we have to see. But in the next slide, you will see how likely it is that we have Bitcoin broken, like in the next 5 years, 10 years, 20 years, and so on. So if you look at this chart, how long it will take for Bitcoin to be broken by quantum computing. And here you also have that nice cumulative chart. And if you look at the chances here, it probably takes around 10 to 20 years to break Bitcoin. And what we should not forget is that we have this physical, and the physical qubits are really very noisy. So in this case, it takes 2,500 perfect logical qubits to break the encryption and 4,000 to break the ASIC encryption. It's important to know that you need about 10 million physical qubits to get 10,000 logical qubits. So this is very important. It does not, it's not sufficient for the quantum computer designers just to have these qubits. There's so much noise, there's so much errors in these qubits, and the more qubits connect to each other, the more noise there is, and it's very hard to get clean information out of that. So the risk that actually Bitcoin is going to be attacked by a quantum computer in the very near future is very small. And you have to remember, if this would happen, we probably would have much higher or much more problems instead, not just Bitcoin. Because the encryption, if somebody can hack encryption, everything can be hacked. Your bank account can be hacked, every company can be hacked, the whole internet with the HTTPS protocol can be hacked, and so on. So this is not likely to happen very fast. One more thing, in the case of Bitcoin, it is actually possible that we could go in and change the protocol, so we could change the Bitcoin code. We could implement a different encryption model, a quantum safe encryption, but this will lead to more and more decisions we need to take, because if you implement a new encryption into Bitcoin, for example, you may end up with older wallets or wallets that have been lost, that they would not be able to restore their value. Because if we change the encryptions, it's very likely that, you know, your private key will not work anymore on wallets. And if you don't do the update or whatever, but maybe there will be just a web interface where you can put in your old private key. It's not advisable, of course, to do that, but maybe we reach a point, a time where this is something everybody's doing and it's recommended and it's okay to do. So maybe there will be some mechanism that if we have to make the algorithm of Bitcoin quantum resistant, then we could do it. Just keep that in mind. And how it's gonna be done, we don't know now. But the community would have to decide, and the community would have to agree on that, and then we would be able actually to do that and have a quantum resistant algorithm inside of Bitcoin managing everything, and we would be safe for the next 100 years probably. So I hope this video was helpful and I showed you some interesting new parts. We continue this series about Bitcoin, and if Bitcoin is able to be hacked, we're going to talk about hacking. We're going to talk about the risk of the code, the risk of other companies maybe taking it over, the risk of a coming crisis, if Bitcoin will be stable in a crisis, and all of that. If you watch this on YouTube, please give this channel a thumbs up and subscribe, and I see you in the next video. Take care. Bye bye.